In our previous video, we talked about, we gave an introduction to monolithic services. In this one, we'll go into a little more detail. If you recall, monolithic services are split into three tiers, typically three tiers. The first tier is the presentation tier, where we're presenting the UI to our users. The second one is the business layer, which does most of the computation work, right? It takes the data from the database and it sends it back to the UI and ultimately back to the user. And the third one is we have the database layer, which is essentially a connection from the database, from the application to a database somewhere. It could be directly on the machine, or it could be, in a different machine. So this is our monolithic application. And these components are deployed together. This is the keyword, deployed together as one application, one single app, right? So as our user is sending requests to our instance, right, our application as a whole would then respond to our user. And in the scenario where we have, say, 1,000 users, and it's causing our system to experience more load. And if you recall, we have a couple different parameters that are bounded by hardware, which is CPU, RAM, and hard drive. There are two ways of scaling out our application. In this case, the monolithic application. The first way is vertical scaling. Which essentially just use money to buy bigger machines. Use money to buy bigger machines. So instead of say 10 gigabytes of HD, we now have 100 gigabytes of HD, right? The limitation of using vertical scaling is that we're limited by our hardware. We can only scale out vertically, scale out finite, because we don't have infinite number of cores. So the second way of scaling is horizontal scaling. Horizontal scaling just add more machines, so use more money to add machines. Instead of having just one 3-tier, right, hitting the database, we now have 2 of them. And they sit behind a load balancer. And the load balancer uses some kind of load balancing algorithm to load balance the requests into these different machines. Right. And of course, you can have n number of machines, right? You can add one more. So what is the limitation here? Well, let's say if your application is complex, right? And you have, say, several different features. Let's say you have a login feature, right? You have a user management feature. You have a shopping feature. Which includes add item, remove item, buy item, etc. Right? There are different functionalities of this application that we're building, right? If all of them sit in this single machine, right, they actually use different number of QPS. So QPS ratio is different. Right? User management. You only need to log in once. Log in, not used not very often. Right? User management. Maybe not use. You don't update your status very often on the website, so maybe this one not used often. But shopping, you're adding, removing. This one is using maybe, let's say 1,000 times more than others, right? Than others. But because they all sit in the same application, right? It takes up space from a single machine. So they're all in the same machine, but because one feature uses more IO, right? The user management doesn't use as much IO as shopping, so we are essentially scaling out features that we don't need, right? Because, as we're scaling out this whole application, user management gets scaled out as much as shopping features, even though shopping feature is used 1,000 times more, right? So we're wasting our hardware if we, you know, scale out user management the same as the shopping feature. So what is the solution here? Well, again, the solution here is make the system distributed. As we discussed before, distributed systems just split out these components into its separate components. Right? So instead of having a 3-tier application that sits on the same machine, as we discussed earlier, we have 3-tier application that sits on its own machine, right? And they can all communicate with each other bidirectionally or single directionally. This may be the presentation, and this is the business, and this is the database. And they can all communicate with each other sitting behind a load balancer. Of course, request is coming in and it's hitting the presentation layer first. Now, if we are using heavy database access, maybe we can scale out database independently. If there's a lot of compute, right, we scale up the business layer individually, right? So this is horizontal scaling for distributed systems. And as you can see, right, maybe the database layer doesn't use as much RAM, right? So maybe we can get smaller machines with less RAM because it doesn't need as much RAM, right? Because the database layer is talking to some other database, right? So the storage is actually happening here, right? The database layer simply is just a connection to the database. So it uses less RAM. And maybe it uses less RAM, but it could use CPU, right? To access the storage. Maybe it needs more CPU. Same as business. Maybe business requires more RAM because it's doing computation. So depending on the characteristics of your individual components, they can be scaled out in their own way to accommodate the hardware load as we get more customers. I hope that makes sense.